In this video, I'm going to show you how to create an Angular frontend for your REST API. So we have the product API that I've been building in the previous videos, and we're just going to start off by cloning that repository, and then we're just going to build on top of that one. So you can start off by just writing git clone, and then just inserting the URL here. Once it's done cloning, you should have a directory that looks like this. We have our API project, our application project, our domain project, infrastructure, and then we have some other files here. So we can just start off by building the project and running it to see that everything works as expected. So if we open up a terminal, we can just go into the API project, and here we write .NET build. Now that it's done building, we can run the program. So we go into the output folder, and right here we should have a file called api.dll. So the project was called API, so we're just going to execute that one. And now it's running. But before we're going to build the front end for it, we're going to make one change to the API. Because the front-end application is going to request some data from this application, but there is a default security preference in it that is going to deny some requests. So we're going to go into the API project and we're going to edit the program.cs file. So we're just going to go back a little bit. So if we take a look at the contents of this folder here, we have the program.cs file somewhere here. It's this one. So we can either just edit it straight away from the terminal, or we can open some kind of editor. So I'm just going to use text edit. So if we take this one here, open up the folder, and then we have the text editor with our program.cs file here. And what we're going to do is we're going to add this thing called cross-origin resource sharing. So in short form, we just call it CORS. So what we're going to write is builder.services.add CORS, like this. And down here, we're going to enable the CORS. So what we're going to write is, and by the way, I think we have to write add with capitalized because we don't do camel case in C#. Gonna write app.use CORS, and here we're gonna write options. So we have some configuration options for the cross-origin resource sharing. And we're gonna write options, allow any origin, options.allow any header, options.allow any method. And what these lines do is that once we're sending HTTP requests from our front end, we don't want these HTTP requests to be denied. So that's why we write this. And right now we're just in development. We have not deployed this code right here, so it's not a security concern. What you can do is you can always just put this into our conditional expression here that evaluates whether our app is in development or production mode. So here there will be no security concern in terms of your production mode, because this will only be triggered in development. And we can save this file right here, and then we can close it, open up the terminal, write .NET build again. Then we go into bin, then we go into debug, then we go into .NET 6.0, and we write .NET API.dll. And now the program is running. And now we're ready to send some requests from the front-end application that we're gonna build now. The easiest way to get started with building the front end is just opening up a new terminal. And we're just gonna go back a couple of folders here. And when we're here, this is where we're gonna build the front end application. And we're gonna use the command line interface from Angular to do so. So first of all, you can figure out if you've installed the Angular CLI by just writing ng. And it will tell you that you need a command in order to get moving on. So if you write ng new, for example, this is a valid command, and then it's gonna ask you what you wanna call it. But if you get a response that it doesn't know what the command is, you need to write npm i-g add angular/CLI. This is the installation for the Angular command line interface. And if you're on a Unix system, you need to write sudo and enter your password because it's a global installation. And now that you have this done, you should be able to write the ngnew command. So it should look like this. So we can just call it frontend, like this. For now, we can just say no to Angular routing. And I prefer to have this kind of style sheet. So you can go with perfectly normal CSS, that's not a problem. SCSS is built on top of CSS, so you can still use normal CSS in this style sheet. But we'll get back to what that means later. So now it's done installing all of our dependencies. It ran an npm install, which means that if we go into the front end folder here and we take a look at the contents, we can see we have the node modules. But we still have all of the normal stuff that we know from Node.js. So there is the package.json. This is just where we keep all of the listed dependencies before they are installed. There's a README file. There is a tsconfig file because Angular uses TypeScript. And then we also have this file called the angular.json. And angular.json just specifies how the program is going to be built. We also have a file called karma.conf.js. This is for a testing library called Karma. We're not going to use it, but Angular just puts it here by default. Angular also puts testing files inside of our components, and we're not going to use those, so you can delete those if you don't want to have them. We'll go into the source folder here. And in here, we can see that we have this thing called app. And the app component is a default component that will always be built when you start out with Angular. So the app component is the entry point to the application. And the entry point to the Angular application is triggered from the index.html file here. So if we take a look at the index.html file, we can see here under the body that we have this little tag, and they write app root. So app root is the selector for the app component inside of the app directory here. So if we go into app here and take a look at what's here, we have something called app component.ts. If we write out the contents of the app component.ts, we'll see this selector here, app root. And app root is just what we insert when we want the app component to show up. Now what we're gonna do is we're just gonna run the application and we're gonna take a look at what's there. So the way we run an application in Angular is that we're gonna use the ngserve command. And just make sure that you're in the directory that has the package.json file. So if you write ls, we can see that we're in the directory that has package.json right here. So we can now write ngserve. And now it'll tell us that our application is running locally on port 4200. So it will say Angular Live Development Server, which means that for us to get the application into our browser, we need to send a request to the Angular Development Server. So if we open up a browser here, I'll just make it a little smaller. So here we have Chrome. And if I go to localhost port 4200 here, we'll get this application. So now what is all this? Well, I'm glad you asked. We can go in here, just open another terminal, and we'll go to this component called, we'll first go to source, cd source, cd app, and inside of this folder we have something called app component. And the HTML file specifies how this page is going to look. Right now we just have one component, and all of the contents is inside of this file. So if I write cat app.component.html, I'll get all of this stuff. So all of this stuff is all of the markup, so the CSS and the HTML, and all of the things that we call the template. The template here just specifies the visuals of the page. And we're not going to use any of this, so we can just delete it all. In order to delete it or do any changes in general, I prefer to use WebStorm. So inside of WebStorm here, we can just find that same file as before. It was in app component, and it's this one. So we can just delete it all. And now if we go back into our browser here, it'll now be totally empty. So Angular does what's called live reloading, which means we don't need to constantly run our application again. It's just constantly updating. So if I put something in here, hello world, and I go and take a look at my browser, I now see hello world here. So that's great. We'll start making some changes to the application now. So the first thing that we're gonna do is we're gonna install a library called Axios. And Axios is an HTTP client. So what we're going to use that for is to send requests to the REST API. So when we're inside of this front-end directory here, we can just write npm I Axios like this. And now it's installing, and if we go into the package.json and go under dependencies, we should be able to see that we have Axios installed here. So now we can start sending some HTTP requests. And before we do that, we'd like to create the file that will contain all of the Axios logic. So I go into source, and then I go into, I'm going to create a new directory here called services. I'm going to go into services, and now we're going to write G for generate service HTTP. And now it created two files for me. All of the files that say spec means it's the test file. And we're not going to use the test files right now, so we can just start off by deleting all of the test files that we have. So we have one called app component.spec.test. We can just delete that. And then we have the services here. I will just delete this spec file as well. And we can just say always add here. And this is what a service file looks like. So right here it will have an import, and it'll import something called injectable. So it just means that this HTTP service class that we have is available in the root, which means that this is just to be used by other components that are other places in the application. And what we're going to write now is we're going to write some configuration for Axios to start sending some HTTP requests. The first thing that we're going to do is we're going to import Axios. So we do that using the import keyword. We're just going to write Axios from Axios. So where is it importing from? Well, we have this thing called node modules here. And node modules has a folder called Axios. So it's alphabetic and it's right here. All of these other things, what are all these things? Well, they are all of the dependencies that our dependencies rely on. So when we install Angular, we also install a bunch of other things that Angular needs. So that's why you have so many folders inside of the node modules. So in order to get started using Axios, we need to figure out where are we gonna send our requests to. So we're gonna send them to our REST API, and we use localhost port 5001. So we're gonna write export const custom Axios equals axios.create, and inside of this create method, put curly brackets, and here we put base URL colon and then the address. So HTTPS localhost port 5001. This is the base URL. So we can add some things after this base URL, like /products, /bank, /yada yada yada. It's not important what's after. This is just the base URL, right? So we're gonna make a function here. We can call it getProducts. And this getProducts is gonna use this custom Axios thing we created here. So we can write custom Axios.get. Notice how these functions, they have names that correspond to our HTTP methods. So we can say post, we can say put, we can say delete, but we're just gonna start off by getting. So we're gonna send a get request to this base URL /product. So we make a string here, /product, right? And this is not all of it. So the thing about sending HTTP requests from a front end and getting some data that can be a little complicated is that we're working asynchronously. So we don't know when the REST API is going to respond. Maybe it's going to take a long time, maybe it's going to take a short time, whatever it is. So there are several ways we can deal with this kind of funky time delay. And either we're going to write this then method afterwards, then there's going to be a response, and then we can do something with that response. So we can, for example, write response, and then we make a little scope here, and then we can use this response to something. But the way that I think is easiest to do this HTTP request is just writing. I'm gonna make a little bar, a little const here, and then we're gonna give it a name, data equals custom Axios.get, and we're gonna use this keyword await. So right now it's gonna say that we cannot use await because this is a synchronous method. We need an asynchronous method. The reason why we're using the await keyword is because we don't know when we're gonna get a response. So we send this HTTP request somewhere to some server in the world, but our program doesn't know when or if ever we're gonna get a response. So once we've gotten the response, we can compress it into this variable called data right here. And then we have the HTTP response here. And the HTTP response contains a lot of things. That's right. That's why when we write data dot, we get a lot of things here. We get like a status code that could be like a 404 or a status code 200 or whatever. And then there's gonna be some headers, and there's gonna be some text maybe. And what we're interested in is getting a list of products. So the data that we have here is just the products. So I should probably name my own variable differently, just so it's not confusing. So we can say HTTP response, and then we say HTTP response.data, and in here our products will be. So we're ready to use this function now. And if we go into our app component, right here, we don't have anything. We have a tile, and the tile is front, and we can just delete this. We don't need it. And we're gonna make a constructor because we need to inject the service, the HTTP service we just created, into our app component. And the way we do that is just we write private, give it a name, HTTP, and then give it a type. So this is a perfectly fine dependency injection in Angular. So we don't need to write like a private HTTP and then take this HTTP in here and put it equals this one out there or anything like that. This is perfectly fine. And now we can make a function. So we can say get products. And then we can say this.http.getProducts. And it's gonna say, hey, do you want to do anything with it? Because this is a promise. And a promise we need to resolve. So we can either use the then keyword, or we can just use the await keyword, just like before. And then we just make this function asynchronously. And in order for this function to trigger once the program gets to the app component, we can use an interface called ngOnInit. So init stands for initialize. So if you write the implements keyword and then just write ngOnInit, we're gonna be offered to implement this interface. We can just take this line here, just put it straight into the ngOnInit, because we don't really need our own function here. Then we just say that this is an asynchronous function and it should not return anything. So if we want to console.log this one, we can just give it a name, await products equals const products equals await, like this. And then we can output it using console.log products, like this. So before we're ready to start sending some requests from the Angular application, we need to make sure that our database is actually existent. So we're using SQLite still, and we just cloned it before, which means that the database has not been rebuilt. So before we start sending anything, just go into Postman, send this rebuild DB, and now we can also put a product inside of it, just to see that something actually shows up inside of our console in our browser. So we're just gonna send a post request here. We're gonna go to body, raw, and we're gonna send a JSON. And here we're gonna say price 10, name, mock product. We're gonna send this. And we're gonna get a 201, so this is all right. So what we expect to happen now is that our ngOnInit is gonna go to this method called getProducts, and now we're just gonna console.log this result afterwards. So the getProducts just sends an Axios HTTP request, and then it's gonna return the data from that request. So we have an HTTP response, but we just care about the data inside of this response and not the status code and all kinds of other things. So if you go into the component, open up a browser here, and inside of the console of the browser, we can see that we get this mock product that we just inserted into the database. So we know that our Angular application is capable of sending HTTP requests, and we also know that Axios works as expected. So now we're ready to start building the graphical user interface with Angular. And we're going to use a library called Angular Material, just because we don't want to create all of the CSS and HTML markup ourselves. We can use a library for it. So there's this site, material.angular.io. If you go here and click Get Started, they're gonna have a little command for you here, ng-add. If you just copy this and you go to your console here, just be inside of the Frontend directory, and you paste this. This is how you install the Angular Material. And Angular Material is what we broadly categorize as being a CSS framework. So they're going to ask you about themes and whatnot. We can just pick this one, and you can just say yeah to some of these things. Yes to animations. We're not going to use a lot of these things that they ask us about, but it doesn't matter if you say yes or no for this demonstration. If you go to your package.json, right now you should be able to see this one, Angular Material. And we're ready to get started with some Angular Material. The file that we're gonna edit is the one called app.component.html, and we're gonna put some HTML code in here. So I'm gonna start off by making a div. This is just a simple container, and inside of this container we're gonna put what's called a form field. So we're gonna make a form that we can use to send a new product to the API. So I can make this little tag here. This is how we start HTML elements, and we can write met form field, and it already knows what it is. And it's gonna ask me, I do want to import this, and we just say yes. And inside of this form field, we're gonna put an input. And input is just a very simple input field that you can write some characters into, and material leverages this input element. We can do this form input here, so it's gonna look visually more pleasing than if it was just a simple input. And what we're gonna write now is ngModel, and ngModel takes the value of this input field and then it syncs it up with some variable that we have inside of our component. So I can write something called product name here and say create a field product name, and we can just declare it as n. You could also say it's a string and set it equals to an empty string. This is all right as well. And now if we write something inside of this input field, we can get the value of the input field as the product name, which means if I make a button, let me just make a quick button here, so I can use material for this as well. By just writing a button. This is a simple HTML element, and then we can write mat raised button. They have different versions of buttons. I think this one is good looking. And now we can write click. So click can trigger a function, and we can just make a function called write product name like this. And this write product name, we can just console.log our product name variable. So we say this.product name. And now if we open up our browser, we can see we have this bar here. This is where our form field is. So we need to get hold of our button. We have it somewhere here. Let's just and it's because our button doesn't have any text on it. That's why we couldn't see it. So we can just write click me. And now if we go back to our page here and we write some text, open up console, we get this text here. So we can use this to start sending some HTTP requests with a custom body. Before we get that far, we need to add another field. So we'd like to have two fields, one that is for price and one that is for name. So we're gonna add mat form field, and inside of this we're gonna just add input, and we can say type here and write number. Now it's a dedicated number form field because price is a number. I'm gonna call it mat input. And now we're gonna write ngModel, just like before, and we're gonna sync it up with something called product price, like this. And we can just say this is a number, and this should start at 0. So 0 is a default value for it. And now we can put these on separate lines by doing like this, and put the button here on a separate line like this. And if we open up our application, this is what it looks like now. So let's start sending this data. Inside of our app component here, we can make a method called create product, like this. And now we can say this HTTP create product. And we're gonna make this new method inside of our HTTP service. But first we're gonna figure out what kind of data are we gonna send. So we can make a new object here. Let DTO equals price, this product price, name, this product name. And then we're just gonna inject this DTO into this method. I'm gonna say create product. So now we're gonna use Axios in this side of this HTTP service to send the request. So we say await custom Axios post, and it's still gonna be product. And now we're gonna attach this DTO with the request. And just like before, if we use the await keyword, we need to make this function asynchronous. So we can say return await custom Axios.post. So now we're sending a post request to the product relative URL, relative from this one, right? So HTTPS localhost port 5001/product. We're gonna send this DTO. And if we go back in here, we can say await here as well, because we had a synchronous function we were calling, and we can give this one a variable. So const result equals, and now we can just log the result here. And actually we can say result.data, because we're just interested in getting the data back and not the entire HTTP response, like the status code and everything. So now if we open up our user interface and we start giving this a name, say product name is hey and the price is this, right click me, and we need to give the click me button a new method. So we write create product in here, write the name, hey, this is the price, and now we get product with ID 2, name hey, price this. So we've gone all the way to the REST API, and that REST API inserts into the database with the entity framework, and it returns the finished product with the ID. And now we have this product in the front end as well. So what we're going to do now is we're going to display all these products, because we have a front end that can now create of all the products. Inside of the HTML here, we're going to create something called a material card. I think material card is a very visually pleasing way of just presenting some things very quick. So we don't need to write our own CSS. The mat card just takes care of that for us. And inside of this HTML tag here, we're going to write what's called an Angular directive. And I'm going to loop over our products. So right now we don't have anything called products, but we do have a method that fetches products. So we're just going to create a new variable inside of our component called products. So we're going to say let p of products, create field products. And right here, instead of logging the products, we say this products equals products.data. And now we can write the products out here. So the easiest way to do it, just to see that it works, is just to write these two brackets. We call it interpolation. And then we use the identifier we created right here. And then we use this thing. People call it pipe. It's the same symbol as when you write OR statements. And then you write JSON here. So we get it in a JSON format. So if you open up the browser now, and we can see that we have our products here. Of course, this is not very visually pleasing. We can make it a little more appealing by just going back into our HTML here. And now we're gonna use some material elements just to style this really quick. So we're gonna make something called a card title. So if we say mat card title, we already have this because it's inside of the mat card module. Inside of this mat card title, we just write the curly brackets here, and then we say p.name. And we can also use something mat card subtitle. And here we can write p.price. And we can also say mat card subtitle again, just to get the ID, just to see that these are different products. Product number. Oh wait, we're gonna do like this: product number p.id. And let's take a look at this. So now we have mod product 1, price 10, product number 1. We need a little bit of spacing here. It's very crammed up. So the way that we would do this is just add some margin. So we can add some margin between the cards by just writing style margin. I want to have margin between them vertically, so I'm just gonna write margin top like this, and then you give it some pixels. So we say 30 pixels, for example. And we can do this between all of our other elements, and probably most importantly around the entirety of the application, so it's not starting in the uppermost leftmost corner. So style margin, let's say 100 px. And this is what it looks like right now. We can just close this out here. So it's already a lot more pleasing. One adjustment that I think we should make is that when we create a new product, we should add this new product to the existing list of products. So what I will do is I say this products.push result like this. We can delete the old function we had just to write the text of the product name. We don't need that anymore. And now if we open up the application and say test product price 22, click me, we get it here. And the reason why we don't see the name and the ID and everything is because that inside of our service method, we don't return the data, we just return the entirety of the HTTP response. So we're gonna make a variable here, const HTTP result. Return HTTP result.data. And now we're gonna test it again. So we say, hey, 1, 2, 3, click me. And now we have it here. I'd like to also add a delete function. So we're just gonna start off by making the delete button. So in material, we have something called material card actions. And these are the buttons that you would typically see at the bottom of some display. So if we add material card actions here, we can have something called a button, just like we added a button before. We're just gonna say mat button here. So if we don't add this mat button, it's just gonna be a basic HTML button and it's gonna look awful. So we're gonna style it just by adding this mat button. We're gonna write click delete product. And inside of this delete product function, we're gonna put p.id. And now we're just gonna create this method, and we're gonna say this HTTP delete product ID like this. And now we're gonna create the service method. So we're gonna use Axios for this as well. So we're gonna say const HTTP result equals await custom Axios delete, and we're gonna write product, and then we're gonna write ID here. In fact, we need to have the ID of the product that we're gonna be deleting in the route. So it's actually not a body that we're attaching, like when we do a post request, we're writing product slash and then the ID that we're deleting. So we're gonna make this function asynchronous, just like the other ones. And we can say this ID, we can just declare it as being any. And then we return HTTP results .data. And in here, we can also declare this as any. After we call the delete product, we need to find the product that we actually deleted, and then we're gonna remove it from the list of products that we already have. So what we're gonna do now is we're gonna say const product equals await this delete product. So now that we have a delete method, we need to actually remove the product here from the list of products inside our front-end application, because it's not enough that we delete it in the database. It needs to be visual in the front end that the product doesn't exist anymore. So what we can do here is we can use what's called a filter function. So we say this.products equals this.products.filter. And now we're going to compare the ID of the just deleted product to the already existing IDs of products in the list. So we can say p.id is not equals to product.id. So the product, that is the result that we're getting, right? And the result that we're getting has one ID. So we make sure that when we delete a product inside of the API, we return the deleted product. If we don't return the deleted product, we don't really know what to delete other than based on this ID. But the problem with that is, what if the deletion fails? Then we start deleting something in the front end that the database has not deleted. So we need to reference this product here and say the ID of this product should be deleted in the list of products that we have. And I think we need to write delete here in the user interface. So now we can pull up the UI here and we can click the delete. And now we can start deleting some things. So we can write some new things here and we can delete them again. Write some new things, delete them again, right? One thing that I also like to do in the front end is to make sure that our the forms only can send the data that we're interested in receiving. So I know we're doing validation on the back end, but I think we should also make sure that we're not unnecessarily sending HTTP requests that will just be met with a rejection on the back end. So what we can do is we can disable a button. And the button we have to disable is actually up here. And we can just write disabled, and there will be this little suggestion with a disabled inside of the square brackets, and we just set this equal to a Boolean expression. So the Boolean we're checking for is product name loosely equals empty string or product price less than 1. So if the product price is less than 1 or the product name is an empty string, then we have a disabled button. So if we open up the UI, what we have now is this. So if we start filling in some stuff, Now we can add it. Delete this. Now we cannot click it anymore. So this is a way of not sending unnecessary HTTP requests that are just gonna be rejected by the backend. Of course, we still need to validate things inside of the backend. We don't know if the clients are gonna be using our dedicated front end or if they're just gonna be sending Postman requests or something. Right now, our graphical user interface is not very responsive. It does delete the products when we click the delete, and it does create the new product when we click create, but I think it's very visually pleasing to have some immediate response on the actions that we take inside of the user interface. And one thing we can use for this is what we call toasts or snack bars. And what they are is a little UI element that will give response when a user takes a certain action inside of the user interface. So the way we can use this is inside of the HTTP service when something is rejected. So how do we know if something is rejected? Well, we can have something called an interceptor. So we're gonna make an interceptor for our Axios client that is gonna be coupled up with this snack bar that can give response. So if we send some HTTP request and it is rejected, we don't just get it inside of the console. We need to get it inside of the user interface. Okay, so what we're gonna do now is we're gonna get this interceptor up and running. So we use our custom Axios that we created up here, and we're gonna write interceptor response. And then they have this method called use. So use can either be on fulfilled or it can be on rejected. So if we have a response that is fulfilled, we can start delivering some custom message. So let's say that we have a 201 status. That's when we create something. We get the HTTP status code 201. We say if response.status equals 201. We want to do something. So we can also say, in case that something is rejected, something else will happen. So we could say return response, because an interceptor still needs to return something at the end. So we can have some action before we get to the return statement, and after this we can have some other path in case that the HTTP response is rejected. So we're gonna say rejected, and just like before, we get to have some conditional here. So right now we're just gonna say return rejected. But inside of this conditional expression we have here, we're gonna use this snack bar I was talking about. And now it's gonna all come together. Private mat snack bar, mat snack bar. We have to go into our module and add this inside of our providers, mat snack bar, and we also need something called overlay, because a snack bar is something that goes on top of the other things, the other elements on our screen. And we go back into the HTTP service. We're gonna say this snack bar open, and we're gonna say great success. Let's open up our user interface here. Gonna give this product a name, my test product. We're gonna give it a price, 1, 2, 3. Click, great success. So now we have a responsive UI here, right? But we also wanna have a response in case that our request gets rejected. So if the response here is a rejected response, and it's due to the client doing something they shouldn't be doing, we know that the status code starts with a 400. So like a 404 or 401, whatever. We can say if rejected response.status. And then we just say is greater or equals to 400. And rejected response status less than 500. We're gonna say snack bar open, and in here we can do something really cool. We can say rejected response.data, because our API returns what's wrong, and that's because we use validation on the API, and therefore the message that we put inside of our validation logic can get returned to the client. And I'm just gonna show this really quick. So in order for us to send something that we have disallowed inside of the API, we should of course enable us to send this data. So we can go back into our HTML here, and we just say if name is not null, but we can still create a price that is invalid. So we can just say a test product and right click me. And now we get this thing, price must be greater than 0. So our graphical user interface can actually tell us what's wrong with our request without us having to figure out ourselves. And we can go back into our Axios right here. Right now we're just returning the rejected, but we actually need to handle the error. So we can write catch error, and we just write rejected here. And we're gonna import this. We can also have a conditional that checks if it's an internal server error. So we can say else if rejected response status greater than 499. Then we can just return this mat snack bar something went wrong, like this. So just to summarize, we now have an Angular application, and it's capable of sending HTTP requests to an API that can store things inside of a database, so we can delete and we can create again.